Hello and welcome back to the Geographer's Craft blog. Today we'll be working with Lab2, Part 2, which is the populated place centroids. In the first part of the lab, we mined data from the U.S. Census Bureau and the U.S. Geological Survey. Now that data came in text files, and we converted those text files into Microsoft Access into different fields delineated by either a comma, a pipe, or a space. And then we also learned how to import columns that were fixed width. Now the next step in the lab is to take these two separate tables that we have and convert them into one table. And the way to do that is we have all this data and we're going to find a way to connect these two tables together. So something that's unique about both of these. And what we're going to use in this lab is the place names. And now the place name are just places in Texas, real cities and towns and villages. As you can see, we have some here too. And we're going to use that as our connecting factor to convert these two tables into one new table. So if you go to Create, and over on the right, the Query Design, it's going to ask you which tables you would like to import. So we're going to choose the two tables that we're working with, and close that. Now the first thing you can do is you can expand these to see what you're working with. So you can see what we have on these tables is it's just our header for our field name. As I said earlier, we're going to connect these two tables together using the common names of the cities that these two tables have. So to do that, all you have to do is click on the name and drag it over and unclick it on the feature name. Now you have this file that's connected. It can't be broken. So the next part is as simple as just adding which new fields you want, because there's a lot of erroneous data in these tables. We don't need all these extra fields. We're going to make this relevant to us. So all you have to do is double click which information you would like to appear in your new table. So the name, Texas, which would be our state, and then we want the latitude and longitude for the purpose of this lab. Now you can also left click and drag those down if you'd like, but I think the double click is easier. Now the data that we would like from the other table is the city name again, the latitude, and the longitude. Now we're ready. If you go to the top left view, you can see the query results. So this is our new table. And as you can see, it's just the data that we need, that we want for today's lab. And as you can see, it's the name of the cities, so Addison and Addison, Baird and Baird. And then we have our latitude and longitude. Our latitude and longitude, however, we run into some problems. If we wanted to import this into ArcGIS or mapping software using an XY event, we would have to be sure that the latitude and longitude for the second table are in decimal degrees. As you can see, they're in degrees, minutes, seconds, and these are in decimal degrees. So we're going to change that in Microsoft Excel. So we're going to go ahead and right click and save this query as Lab2. Now I'm going to go to external data. Remember, we imported our data here, the text file. So we're just going to go over to the right a little bit, and we're going to export it. And so you can see it tells you to export to an Excel spreadsheet. So if you click on that, and be sure it's saved in your lab folder. All right. Now that should be in Microsoft Excel now. So let's go ahead and go to Microsoft Excel and see if this actually works. Open. All right, check it out. That is our file from Microsoft Access. As you can see, we've got our feature names, our header, our latitude and longitude. As I said earlier, the latitude and longitude as it is in degrees, minutes, and seconds, and that's not going to work for an XY event into Microsoft or into ArcGIS. So the next step is let's turn these into decimal degrees. And so we're going to create some new headers here. So this is going to be latitude degrees, latitude minutes, latitude seconds, then latitude hemisphere. We're going to do the same thing with longitude. So longitude degrees, longitude minutes, longitude seconds, and then the longitude hemisphere. And then we're just going to have the longitude and the latitude and the longitude. These are going to be once they're converted into decimal degrees. So it's really easy. All we have to do is learn some simple equations. So the first thing we're going to do is we're going to separate each of the degrees, the minutes, and the seconds individually. So the equation we're going to use equals value, mid. The equation is simple. Try this again. Equals value. Be sure we're case sensitive there. Value, mid, f2, comma 1, comma 2. Now what this is saying is that we're going to take, starting with the first digit, which is in f2, which is 3, we're going to take 2 digits and separate those out. So that's going to be 32. Let's see if this works. There you go. Now we're going to want to fill this down for all of our latitude and longitude. So if you see that little square in the far right bottom right corner, if you click that with your crosshairs and you drag it all the way down, all right, you've got your degrees separated. Do the same concept with the minutes. It's going to be mid f2. We're taking it from the f field, and we're going to start with the second digit, and we're going to take 2. Start with the third digit and take 2. Be sure there's closed parentheses, and you have 57, which are your next 2. Those are your minutes. So let me just go ahead and fill those down. Every time you see the pound value, that means that you don't have the latitude and longitude. So that's not a big deal for this lab. And now it's the same simple procedure. We're just going to change the numbers around. Mid, F2. We're going to start with the 1, 2, 3, 4, 5, the fifth digit, and take 2. Make sure it's closed. All right, we should have 42. Look at that. And fill that all the way down. Not that far down. Okay. Now the hemisphere, because it's in the northern hemisphere, remember that's going to be positive. So we're just going to put 1. And longitude degrees, it's the same thing. We're just going to switch around the equation just a little bit. Now for our longitude conversion into degrees, G2 is working with a different column, 1 and 3. We're taking 3 digits because you can see that some of these, there's a 0, so it's 0, 98 degrees, because there's also 100. So we have 96, that looks like it works, so we're going to go ahead and fill that down. Forget we need to fill down that 1 for the hemisphere of the latitude. Okay. Now, our longitude minutes. Going to get very good at typing in these equations. It's going to be G2 again, taking the 4th and taking 2 digits. All right, 49. Okay, let's fill that all the way down. And longitude seconds equals the value mid G2, going to the 6th, and we're taking 2 digits. All right, 45, that looks good. So we're going to fill that all the way down too. Wait for it. Try not to pass it this time. All right. almost done. Our longitude, now it's in the western hemisphere, so if you think of a graph, think of NESW. Some people like the never eat shredded wheat, so N, never eat shredded wheat. So this is going to be your negative side over here, and south is going to be your negative 2, so our hemisphere is going to be a -1, and we can just fill that all the way down. Alright, now all we have to do is convert these into decimal degrees using each individual integer. So for our latitude, it's going to be equals the value, close parentheses, h2 plus I2 divided by 60, because there's 60 minutes in a degree, plus J2 divided by 3600, because that's how many seconds are in a degree. And we're going to go ahead and just complete this. We're going to multiply that by 1, so we know that it's in the right hemisphere. And we're going to get 32. And that matches up pretty close. So now this has been converted from degrees, minutes, seconds to decimal degrees. And fill that all the way down. Right, now all I have to do is complete the longitude. Equals the value of L2 degrees plus our minutes, M2, divided by 60, once again, 60 minutes in a degree, plus N2, which is our seconds, and that's going to be divided by 3600, because that's how many seconds are in a degree. Close that. Multiply that times our hemisphere, which is -1, and you're going to get -96. So our longitude is all complete. And fill that down again. Now, just to complete this lab, let's take a look. Let's take this column, and let's move this over. Now to compare these two latitude and longitude side by side, I'm going to go and I'm going to insert some new columns here by my decimal, or my degrees, minutes, seconds. I'm just going to insert a new column, maybe 2, 1 for each. And I'm just going to go back and I'm going to right click my R at the very top, cut that column out. I'm going to paste it in my new column and do the same thing for my longitude. So I'm going to right click, cut, and then paste. So now we have complete tables with both are in decimal degrees. Now you can see that even though Addison is the same place in Texas, the center of Addison is calculated differently. So the USGS and the Census Bureau, they both have different methods for calculating what they're going to call the coordinates for that. So you can see Addison is a latitude of 32.95, whereas the USGS says it's 32.96. Now this is persistent with all of these. Just to give you an idea that different places have different centers depending on how they're calculated. Now you can always clean up this file if you like. You can get rid of the columns by deleting them if you don't want them. That's a lie because you actually need those. Leave that there. And we're going to save this file. We're going to be done with the lab. So now you know how to manipulate text files from different relational databases, put them into one file, and then convert degrees, minutes, and seconds into decimal degrees. Stay tuned for next week's lab for the geographer's craft. We'll be working with importing XY events into ArcGIS using Microsoft Excel.